video 7, and we're going to look at waves and tides and currents today. And as we think about waves and tides and currents, there are three different motions that are going on in the ocean, but they're very different. They're caused by different things. So there's different forces at work. And we want to look at waves first, and we're going to pause, and I'm going to demo how a wave is the movement of energy through a body of water. And in 6th grade, you studied sound waves, you studied light waves, you looked at earthquake waves, and now we want to think about water as a wave. And so we'll pause and do the demo, and then we will go back and finish our notes. So as you can see, the folks that lined up, their bodies moved, but their feet were planted because the energy was moving through them. And that is what happens in a water wave. And the water wave size is always going to be determined by the wind. On a windy day, the waves are going to be much higher. They're going to have a higher wavelength. And on a day without wind, they're going to be pretty flat. They're not going to have much height at all. And then the length of time it blows. Is it in short blast or is it a constant steady wind? That's going to also impact the height of the wind. So the energy is moving toward the shore, and when you get to the shore, the water just kind of falls over and breaks. And we might have heard the term breaker when we're talking about water. But the water itself is not moving. Now, what is moving the water farther up the shore or farther out is called the tides. So as we get to the edge, the shoreline, the wave height's going to increase because you're running out of slope, out of seafloor. And so we just fall over, and that's when we say the wave breaks on the shore. Tsunamis are also waves. They're really large waves, and they're caused by an incredible release of energy from an underwater earthquake. So again, the energy is moving up from the deep through the water. Excuse me. And they're going to just shove this massive amount of energy toward the shore. And if the wall of water is very tall, which it usually is in a tsunami, if the energy doesn't run out before it reaches the shoreline, it can do a lot of devastation and flooding, like it did in the Christmas tsunami that hit Indonesia several years ago. Waves can shape a beach because as they break on the shore, they're going to pull sand in and out. So beaches are constantly shaped by this water striking the shoreline. Now the tides is what's determined how far up the wave will come or not come. And the tides change 4 times a day. There are 2 high tides, there are 2 low tides, and a tide is basically the interaction of the gravitational pull between the moon, the earth, and the sun. And when we finish our notes, I've got a couple of videos to show you. I want you to see the Bay of Fundy because that is the place where there's the greatest difference in high and low tide in the world due to the shape of the landforms there and the way the water comes into this bay. It really pulls out and it really comes in. And we'll look at a little time-lapse clip of that in a few minutes. There's 2 tides that can occur depending on where the moon is. Is it where we see a full moon or we see a new moon where we don't see anything? And the spring tide occurs when the sun, the moon, and the earth are all in a horizontal alliance. So the gravitational pull is the strongest. And that's when the high tide is going to come farthest up on the beach and the low tide is going to be pulled the farthest out. So that's when you're going to have the widest beach at low tide and the least amount of beach at high tide. And that occurs about once a month. And then the neap tide occurs when you have the sun, moon, and the earth at a right angle, so there is less gravitational pull, and so you've got your best beach for high tide in a neap tide, and you've got your and high and low because it's just not going to go in and out as far during the neap tide. Now when we talk about currents, currents are like rivers of water that run through the ocean, and I'm sure some of you have gone out to the beach and you put your towel down and dropped all your stuff and gone out in the water and you've been playing, and then you come out and you look and your towel is, 10, 15, 20 feet away from where you are exiting the ocean. And that is the longshore current that has pulled you down the beach. That is a river of water within. We have rip currents that occur between sandbars that pull the water in and out. And then there are also very large surface currents that are running throughout the ocean. And I'll show you a diagram of some of these in a few minutes. And these large surface currents, like the Gulf Stream, we've got a picture up there on the wall of the Gulf Stream, but they're going to impact climate. I'm sure many of you saw Finding Nemo, and the turtles and Crush talked about getting in the East Australian current, the EAC, and that current can take you a lot of places. The other day when we were talking about ocean technology, Ben Franklin realized that there was something in the ocean that was making the mailboats go faster in one direction than the other, and he discovered that was the Gulf Stream. So these are all surface currents, and they run to several hundred meters below, but the wind is what is driving these currents. And they're going to move in circular patterns because the earth is rotating, and that's called the Coriolis effect. The Gulf Stream is the largest surface current, and it carries waters all the way from the Gulf of Mexico, which is on the west side of Florida, up across the east coast of the United States, and then it travels across the ocean in the northern Atlantic, and it goes around the upper part of Europe. And that's why Norway is actually warmer than some other countries nearby, because of this warmer current that is flowing. Now, there are some unusual events that can occur due to the currents, and one is El Nino, and occurs every 2 to 7 years in the Pacific. This is an El Nino year. California is already getting a lot of heavy rains in Mexico right now, and we're not sure if El Nino has begun early. It usually begins in December, and that's why it was named El Nino, because of the Christ child. And it's an unusual pattern of winds, and it drives a lot of warm water to move towards South America. And because of this current of warm water, it causes weather problems. It makes some parts of the world drier and some parts of the world wetter. The United States tends to have a wetter winter in an El Nino year. We also have deep water currents, and this is like a giant conveyor belt that runs from the equator to the North Pole and the equator to the South Pole. And it's cold water is more dense than hot water, and so the equatorial is warm water, and it starts moving toward the poles, and as the ocean gets colder and colder and colder as it reaches the poles, it sinks farther and farther into the ocean. And it can take 1,000 years for this current of water, if you travel, one drop of water from the equator to the poles and back to the equator. And so you've got this rising and falling of water that's happening in these deep water currents. So deep water currents are caused by density, and surface water currents are caused by winds.